the last session we have told that Barkhausen criteria, that is, whenever an amplifier satisfies this Barkhausen criteria, it can quite well operate as an oscillator. Okay, here we have taken a inverting amplifier. Okay, for an inverting amplifier, what happens if the input is going to be in this form? The output will be 180-degree phase shift. Just consider our common emitter amplifier. Right? We have taken an inverting amplifier. The input and output will remain out of phase. That is, it is producing a phase shift of 180 degree. It will be producing a phase shift of 180 degree. Clear? Right. Next, just look at the entire block diagram of an oscillator. What it actually means, we have told that for a positive feedback, that is for an oscillator, we should have only positive feedback. Okay, we should have only positive feedback. Okay, if in the amplifier we have introduced a phase shift of 180 degree, listen please, if in the basic amplifier we have introduced a phase shift of 180 degree, the input and output will be of this form. But I want to employ only the positive feedback over here. For an amplifier to work as an oscillator, it should definitely impart the positive feedback. Positive feedback in the sense, the feedback signal and the already existing input signal should remain in phase with each other. Both of them should remain in phase with each other. Okay. If you have obtained a phase shift in your amplifier network, that 180-degree phase shift has to be compensated by our feedback network. That 180-degree phase shift has to be compensated by our feedback network. Okay. Kindly look at the block diagram now. We have taken a basic inverting amplifier, and therefore the input and output are out of phase. Right? We have taken a portion of the output. Okay, look at the shape of your output. We have taken a portion of the output and fed as an input to the feedback network. Okay, whose feedback factor beta is nothing but output of the feedback network divided by the input of the feedback network. We don't know whether it is a voltage or current, whatever the thing, let it be excess by X naught. Right? Here, I should get the same phase with that of your already existing input signal. Therefore, what we have to do, we have to introduce on our own a 180-degree phase shift so that the output, that is the feedback signal and the already existing input signal should remain in phase with each other. That is, the total phase shift should be 360 degree or 0 degree. Clear? Okay. So for an amplifier to work as an oscillator, it should have positive feedback. Whenever we are having positive feedback alone, we can improvise the gain. Okay. So for an amplifier, we need a higher gain as well as a stabilized gain. Then only if the gain is a nominal one, we can create an oscillation itself. Okay. Therefore, the oscillator, what we have to do, if a 180-degree phase shift is introduced in the amplifier network, that has to be compensated by the feedback network. Okay, we can adjust the component. Okay, we can adjust the RC component or whatever the feedback elements we are utilizing. That feedback network is responsible to introduce the compensating phase shift so that the output of the feedback should remain in phase with the already existing input signal. Okay, and that's why we are just making a simple calculation. X naught is equal to AXI. This is we know. So here what happens? The feedback signal and the already existing, this is for inverting amplifier, and hence I hadn't put any negative sign at all. Okay, we hadn't put any negative sign, just we have taken the amplification as A. Okay, the feedback network, okay, we are having a phase shift of 180 degree. This negative sign indicates a phase shift of 180 degree. Okay, if I am going to substitute this equation 1 in 2, okay, we are going to substitute this equation 1 in 2. What happens? Xf becomes equal to minus A beta Xi. Okay? Xf is equal to minus A beta Xi. I want this parameter should be my Xi itself. I want this feedback signal should be exactly the same as that of the Xi itself. Therefore, what is the condition we have to take it in mind? If Xi and Xi will get cancelled, minus A beta is equal to 1. Okay, this can be satisfied only at the cost of minus A beta is equal to 1. Or else, we can say that is taking the magnitude on both the sides. Okay, taking the real part and imaginary part alone and taking the modulus, what happens? A beta should be equal to 1. Okay, always the modulus, the magnitude of your loop gain should be equal to 1. Right? So, if this condition is referred as the Barkhausen criterion. Okay, I want the feedback should be exactly same as that of the already existing input signal. Okay, so in that case, what happens? I have to make this minus A beta should be equal to 1. Okay, and this condition is referred as the Barkhausen criterion. And what is the another one? We have voluntarily introduced a phase shift of 180 degree in the phase shift. Okay, therefore, the total phase shift should be equal to 0 degree or 360 degree. All these things are carried out only without applying any external input. Directly